As a DevOps engineer, I find myself writing a fair bit of tooling that interfaces with Amazon's web services. I'm normally using Python and the Bodo library. Like any good piece of software, we need solid tests. Tests that don't require connectivity are always ideal. This presentation includes a few tips I felt were useful for fellow DevOps engineers. The code samples and test cases seen throughout this talk are available at the following BitBucket repository. Feel free to clone the repo and follow along. Throughout this talk, I'll primarily be covering 5 Python packages. Setup Tools is Python's library for packaging up your project. Bodo is of course Amazon's SDK for Python. Unit Test is Python's standard library testing framework. Modo is a fantastic tool for mocking out each of your Bodo calls. And Coverage will help us measure our project's test. To make running our test just a little bit easier, we're going to make our project into a Python package. We do this by adding a setup.py file to the project's root. At the top of this file, we're going to import a couple of functions from Setup Tools. We'll then make a call to the setup function, giving our package name, version, and a couple of other bits. Packages is a list of directories containing our Python modules, and Test Suite is the directory containing our test cases. Install requires is the list of each package needed to run our project, while test require is a list of each package needed to test our project. And finally, entry points allows us to create system-wide callables to our Python functions. Always remember, the more concise your function, the easier it will be to read it, to document it, and to write test cases for it. On the left, I'm going to explain my function, while on the right, I'm going to demonstrate utilizing it within a Python interpreter. The first thing I do in my S3 module is import the Bodo3 library. I'm going to define a getClient function that does nothing more than returns the Bodo client for S3. To use it, import the function, then use a variable to hold that return. List S3 buckets will use the getClient function, then make a request to Amazon's listBuckets endpoint using that client. We will check the response, then iterate over the response's buckets key, yielding back the bucket's name. To use it, import the function, then use a for loop to print out each of the results as we iterate. Here I see my account contains a single S3 bucket. It's named static. List S3 objects requires a single bucket name as an argument. Within the function, I'm going to use the getClient function, then make a request to Amazon's listObjects endpoint utilizing that bucket. We will check the response, then iterate over the response's contents key, yielding back the objects key. To use it, import the function, then use a for loop to print out each of the results as we iterate. Here I see my bucket static contains 2 files, style.css and style.js. Read S3 objects has 2 required arguments, one for bucket name and one for object key. Within the function, I'm going to call getClients, then I'm going to make a request to Amazon's getObject endpoint utilizing that client. We'll check the response, then return the read value of the response's body key. To use it, import the function, then print out the results. Here I see the contents of my style.css file that's within the static bucket does something with HTML styles. Main is one of my entry points. It's declared in setup.py. It simply prints out each of our buckets utilizing list S3 buckets function, then prints out each of the objects contained within that bucket utilizing the list S3 objects function. To use it, import the function, then call it. Here I show a nice stylized printing of my buckets and objects. Now that my S3 module is complete, I need to write a couple test cases for it. I'll create a new file, in the test directory named s3test.py. Then import some standard libraries. I'm also going to import Modo's mock s3 function, and then each of the functions from my project itself. First off, I'll create a new subclass from unit_test.testCase and create a setup method. This setup method will execute before each of the test cases and is a great place to store some of my constant variables. Here I'm defining a variable for my mocked bucket, my object, key, and value. I'll be utilizing these throughout my test cases. I'm then going to create a new method named ModoSetup. Notice this method is decorated with mock s3. This is so that each of my calls that utilizes Bodo will no longer hit Amazon, but will hit the internal mocked references Modo provides. In this method, I use my getClient function to get my S3 client. I then simulate bucket creation and file upload using the constant variables stored in setup. Without this, our mocked S3 environment would be completely empty, containing no buckets or objects. Okay, so we are now ready to write some test cases. I'm going to take each of my project's functions and create a test case for them prefixed with test underscore. This pattern is so unit test knows to run them as a test case. In test getClient, I'm using a variable to hold the return of my getClient function. I then use unit test's method assert equals to verify that the client's endpoint.host is that of the expected S3 URL. If it is, this test case will pass. Notice how test list S3 buckets is decorated with mock S3. As mentioned before, this will force my Bodo calls to hit my mocked environment rather than Amazon. Within the function, before utilizing my project's function, I run the ModoSetup method. Recall this populates my mocked S3 environment with the bucket in object. Now that the S3 environment is set up, I will use my list S3 buckets function and store each result in a list named buckets. Using unit test assert true method, I'm going to verify self bucket, which is a constant variable defined in setup, is within the returned list of buckets. If it is, this test case will pass. Test list S3 objects will again decorate with mock S3, then run a ModoSetup to set up my S3 environment. I can now call the list S3 objects function utilizing self.bucket constant variable, which I defined in setup, and store each result in a list named objects. Using unit test assert true method, I'll verify self key constant variable, which is defined in setup, is within the return list of objects. If it is, this test case will pass. Test read S3 object will again decorate with mock S3, then within run ModoSetup to set up our S3 environment. I can now call the read S3 object function using self bucket and self key constant variables and store the results. Using unit test's assert true method, I will verify the stored content is equal to the expected self value constant variable. If it is, this test case will pass. And finally, we have test main. We will begin and decorate with mock S3 and then within run ModoSetup to set up our S3 environment. Since this function prints out rather than returns, it's a little bit trickier to test. I'm going to redefine my standard output to a string IO object, then I could call my project's main function. After execution, I'll store the value from the string IO object. I can now use unit test assert true method to check if self bucket and self key constant variables are in the stored results, as well as check if the stylized formatting is in the expected format. If they are, this test case will pass. With traditional means, we will run the Python's test suite. This is great to see if our test cases pass, however, we don't see how well the test cases cover our project. Let's rerun our test cases, but this time let's run it through coverage. We can now report on the coverage results and see how much of our project is actually covered by those test cases. The report gives us useful information like the path to the module, percentage of the module's coverage, and if there's any missing line numbers To make code coverage even nicer, we have an output type of HTML. This will look a lot like the command line report, but we're now able to click into each of our modules. If any of our modules have missing bits, like I've intentionally added here, it will highlight in red blocks, letting you know that these lines were not covered in your test cases. Seeing this would probably make you think, maybe I should update my test cases or add additional test cases, to cover as much code as possible. Alright, for those of you who like to see this in action, I've put together a little demo of installing the package all the way through to running the test cases. I'm going to start by creating a new virtual environment within the current directory. I'm going to name it VNV. I now need to activate this virtual environment, so I'm going to source it in. I'm now ready to install my package using the setup.py. Just going to run the traditional test suite, see what it looks like. Those tests look good. I'm going to rerun with coverage to get my coverage results. Should expect the same results. Now I could go ahead and report using coverage. And there you have it. With BITBUCKET pipelines, we could automatically run our test suite on each of our commits. Notice on the right-hand side, we have a builds column. This is showing if my test was successful or not. We could also go to the pipelines page and get a neat list of each of our runs and the results of that run. Pipelines leverages the power of Docker, so we could easily install our project using our setup.py, use any style linters, and run our test cases. And like that, a familiar coverage report is just a click away. To learn more about BITBUCKET pipelines, check out the following page. I hope this presentation helped you write some test cases for your Python code, as well as better understand how to mock out Modo. Thanks.